Hi folks, Mr. Long here. We're going to work on some row operations with matrices for 3x3 systems of equations. So it's a system of equations, x, y, and z. You're trying to solve for each item, or each variable rather. Actually, each unknown. They're not variables anymore. In fact, they are placeholders. So here's a system of equations, and what I did, I made these up. So I don't really know what the answers. I know the answer is going to be 1, 1, and 1. I'll just share with you how I did it. The easiest systems to work with are when x, y, and z are 1, 1, and 1, or 0, 1, 0, something like that. And so what I do is I just picked random numbers here. I didn't want anything to be a 1 coefficient in the first column, but I just picked 3x, 5y, and negative 7z. Then I know since x is 1, y is 1, and z is 1, I just work with my coefficients. So that's 3 plus 5 is 8, minus 7 is 1. 2 minus 1 is 1, plus 4 is 5. 4 times 1 is 4. Whoops. 4 times 1 is 4. 0y plus 1z is 5. And now we're going to work with a really great web page that I found today. It's called a Linear Algebra Toolkit, or it's called the Linear Algebra Toolkit, and specifically row operation calculator. It is an applet. And I've already entered this matrix in. At the first page, you enter in the matrix that you're going to work with, and it does a whole bunch of things. You can do row operations yourself, one by one, which is a great way to learn. You can, you can do auto step, which means if you want to learn from the computer, you can. So it'll do the first step for you, and it shows you what that is, second step, and so on. So it might do, like if you do auto step, will it do it? Let's see, maybe it won't. Auto step. Yeah, there you go. So its first step is to multiply the first row by 1/3. Now I'm going to do something very different from that because I avoid doing fractions at all costs. Anyway, you can see that you can do auto step, go backwards, but you can also get row echelon form, and it shows you the actual answer. So it goes through what operations it would do step by step. So you can see multiplying the first row by this, then do this again. Let's go back. So here's our matrix. Our goal, remember, is to get a 1 in the diagonals. 1 here, a 1 here, and a 1 here. What I have to do in terms of process, though, is I have to, if I get a 1 in this x coefficient, then it's very easy to remove these x coefficients or eliminate them. Then the next step, I eliminate this y coefficient here. Okay, so let's go through it. So one thing that I notice is, again, I avoid fractions. So I could multiply the first row by 1/3, in which case I would certainly get that to a 1, but then I'd be working with 5/3, negative 7/3, and 1/3 here. And I don't want to do that if at all possible. So another strategy I could use is I could just take the negative row 2 and add it to row 1, in which case I'd have negative 2 plus 3, which would be 1. So I'm going to go negative of row, or negative, let's see, negative 1 times by the second row added to the first row. Good. So now you can see there's the new matrix, and I've got a 1 in the first entry. So now it's very easy now in the next couple steps. I'm just going to add negative 2 of row 1 to row 2. Negative 2 of the first row to the second row. Okay, and now I have a 0 there, which is what I wanted. And now negative 4 of the first row added to the third row. Okay, I've got that. So now I've got a 0 entry here, here, and here. The next step, I need to get a 0 entry right there. Life is certainly easy if oh, by the way, folks, once I get a 0 here and a 0 here, I no longer am working with the top row. Why is that? Well, if I start introducing the top row in operations with the next two rows, I'm just going to reintroduce that x coefficient, right? Since this right here, what this means now, since I've got a 0 here and a 0 here, I've actually got a 2 by 2 system. So now it's really just a grade 10 problem, right? All I have to do is, as soon as I get zeros here and here, I'm into a grade 10 problem. It's a 2 by 2 system. Negative 13y plus 26z equals 13, and negative 24y plus 45z equals 21. Okay, so I need to do some more row operations. And I'm looking at this, and it's always nice, of course, if we can avoid fractions. But to do that, I'd have to multiply this one by 24 and this one by 13. But the way this computer program works, you can actually only add multiples of one row to another row, or we can divide a row. But take a look at this. My goal is to get this to be a 1, right? Well, look at this. And even if I have to get fractions for just one row to get this last part out, I would do that. So if we look at this, negative 13, 26, and 13. Well, if I just multiply that row by negative 1 over 13, which is the same thing as dividing by negative 13, I'm going to get a 1 there. So now I'm going to multiply the second row by negative 1 over 13. Look at that. Now I'm good to go. So now I just have 24 of the second row, and I'm going to add that to the third row, and now we'll have y eliminated, the y coefficient eliminated. So we've got zeros in the correct locations. I just have to take this negative 3 and divide by negative 3 to make it 1. So I'm going to multiply the third row by the reciprocal, negative 1/3. And look at that. Now I have what's called row echelon form. So at this point, what I would do is go over to here now and go back and do some more algebra. I know from this third line that y equals 1, or z equals 1 rather. Z equals 1. And now I can look at this equation. The second row equation says x minus 2y is negative 1. Well, what I can do is now back substitute. So I have 1y, okay, right there, 1y minus 2z minus, well, actually, I'm going to equals negative 1, and then this negative 2y, 2z rather, comes to the right side of the equation, becomes positive. So plus 2 times by z, and z is 1. Negative, that's negative 1 plus 2, which is y equals 1. And then I back substitute yet again into the first row. So I have z will equal negative 4. This will be plus 11 z minus 6 y, because remember there's an equal sign right here in between. And then I substitute in 1 and 1. And that's not z equals, by the way, that's x equals, sorry, because I'm getting this x right here by itself. So that would be negative 4 plus 11, which is 7. 7 minus 6 is 1. X equals 1. So our solution is x equals 1, y equals 1, and z equals 1. Okay, and that's the process for doing this. So again, I would strongly encourage you to go to the Linear Algebra Toolkit, and it's a great way to get used to doing row operations because you focus on what the operations are and it does the computations. And you might try some of the questions in the homework. You might try making up your own systems. It's up to you, but I would strongly encourage you to do that.